Okay, officers, we have a crisis on our hands.
What is it?
We've had several reports about a circle dealer selling circles with bad chords.
Who would do such a thing?
I know, it's awful. So obviously, they must be stopped. Does anyone need to review their properties of chords?
I do!
I need to!
I love studying chords.
Okay, then let's review.
Okay, officers, let's open your textbooks to Chapter 10.3, which is all about applying properties of chords. Now, most of you should know that a chord is a segment whose endpoints are on a circle. Now let's go look at some properties of these chords that we can use to help stop this circle dealer. Let's start with Theorem 10.3, which states that in the same circle, or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So, in other words, if two chords are congruent, then their two minor arcs are congruent, and then vice versa. Theorem 10.4 states that if one chord is a perpendicular bisector of another chord, then the first chord is a diameter. We could use this theorem to help us find diameters while searching for the circle dealer. I often get Theorem 10.4 and Theorem 10.5 confused, but Theorem 10.5 says that if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. Oh yeah, okay, I remember now. Last, Theorem 10.6 says that in the same circle or in congruent circles, two chords are congruent if and only if they're equidistant from the center. Okay, officers, now that we've reviewed over our properties of chords, let's go catch that circle dealer.
Has anyone seen him?
I don't see anyone. There's no sign of anyone over here.
Darn, I guess. Wait, I see someone. Let's get after him. Hey, you! Stop right there. Do you sell circles?
Yes.
Do you sell good circles?
Yes.
Let me see them. Let's see if she's telling the truth
I
about these
am.
circles and their chords.
Let's look at this circle. Okay, there are two line segments that are congruent. One of the minor arcs of one of the line segments is 90 degrees, and we are solving for x, which is the measure of the other arc created by the other line segment. Let's label this to help with clarity. Okay, we added labels A, B, C, and D to help. Now it was given that AB was congruent to CD, so we can use Theorem 10.3 to help us solve this. Through 10.3, we can prove that arc AB is congruent to arc CD. And therefore, if arc AB is 90 degrees, then arc CD is also 90 degrees, and therefore x would be equal to 90 degrees. Here's the dealer's answer. Well, we got the same thing, so he's obviously not the dealer we're looking for. Let's go.
Hey, you!
You want to buy a
You're
circle?
right there.
Would you like to buy a circle? Do you want a circle?
No, are you selling circles with bad chords?
No, only the good chords.
Give me
I sell
that.
good circles.
Let's look at this circle now. We have two chords that are perpendicular to one another. Let's label it to make things easier. We now see that DB is the diameter because it passes through point Z, which is the center of the circle. We also know that DB is the perpendicular bisector of AC because AE is congruent to EC. Now we can use Theorem 10.4 to find x, which is the length of EC. Well, if AE is 4 centimeters and then AE is congruent to EC, then EC is 4 centimeters, which makes x 4 centimeters. Well, here's the dealer's answer, and it's the same as ours, so I guess he's not our guy either. Let's keep going.
Hey, you!
Hey, would you like to buy a circle? I sell the best circles. My
Are
lucky
you the one
bananas
that's been
loves
selling
them.
circles with bad chords?
I only sell good circles. Ask Bananas here. He loves them.
What is that?
My monkey, duh.
Let me see a circle.
Here's another circle. We have two chords that are perpendicular to one another. Again, let's label to make it easier. Okay, we now know that DB is a diameter because it goes through the center of the circle at point Z. We also know that DB is the perpendicular bisector of AC because AE is congruent to EC. Now, we can use Theorem 10.5 to show how arc AB is congruent to arc BC. So now arc AB is 70 degrees while BC is x plus 20 degrees. So 70 equals x plus 20, therefore x equals 50. Well, here's the dealer's answer and it's the same as ours. Ugh, guess we'll have to keep looking.
Are you the one selling circles with bad chords? Give me your circle.
Here's another circle. This one we'll have to use theorem 10.6. I always kind of struggled with that one, but now it's pretty easy. Let's start by labeling this to help. Okay, so we know that AB and DC are both 10 inches. Therefore, AB is congruent to DC. We can also use theorem 10.6 to prove that EZ is congruent to ZF. So if EZ is 4 inches, then that means that ZF is also 4 inches, so x equals 4 inches. Well, looks like we got another good dealer. I guess we'll just have to keep looking. The bad dealer's got to be out there somewhere.
Hey, you, stop right there. Hey, you, get over here. Are you the one who's been selling bad circles? No, it wasn't me. Are you the one? Yes, Cesar, let me see that.
This dealer tried to make a run for it. Well, this circle looks pretty easy, but let's go ahead and label to start. Okay, so we know that EZ is congruent to ZF. So, by theorem 10.6, we can prove that AD is congruent to BC. Well, AD is 24 centimeters, so BC would also be 24 centimeters. So therefore, x would also be equal to 24 centimeters. What? The dealer's answer is 28, but ours was 24. Well, I know ours is right because we used geometry. Looks like this dealer didn't. Officers, I think we found our guy. This is the dealer we've been looking for. He's the one who's been selling circles with bad chords. Let's lock him up.
You won't be selling bad circles with bad chords now. No, but I thought mine were good. You should be using geometry.